Imagine that you're asked to step out of your house in an afternoon or in an evening on a hot summer day. Which one will you prefer? Obviously, the evening. This is because usually the afternoons are hotter while the evenings have pleasant weather. Now, what is the reason behind this? The afternoons are quite hotter while the evenings are pleasant because the sun's position is different at different points of the day. In this image, we can see various positions of the sun during the day. In the noon, the sun is placed at the overhead, or the sun's position is vertical or perpendicular to the earth's surface. While during the evening or in the early morning, the sun's rays are slanting to the earth's surface. And since the sun is overhead at the noon, therefore we feel hotter in the afternoons than in the evenings or in the early morning. Now, similar to this, the direction of sun's rays also varies across the latitude. Let's see how. Now, as we have discussed earlier, the sun's rays are vertical or perpendicular at the equator. And also, the sun's rays are spread over a small area. That is, they are more concentrated in this region. As a result, the heat of the sun's rays is quite intense in the equatorial region. Now, as we move towards the poles, the sun's rays become slanting to the earth's surface, and also the sun's rays are spread or scattered over a wide area. Due to this, the intensity of the sun rays falls, and therefore places in the higher altitudes experience lower temperature. So now can you relate why the torrid zone experience higher temperature whereas the frigid zone experience lower temperature? So from this figure we can understand that temperature across the globe varies with latitudes. The temperature is quite high in lower latitudes, that is at the equator, and the temperature is quite low in higher latitudes, that is near the poles. Now, have you ever imagined why do we prefer to visit hill stations during summer? This is because the hill stations are quite cooler and they provide a relief from the scorching heat of the sun. The hill stations are cooler or they have lower temperature because they are situated at higher altitudes. We know the density of air is higher in the lower layers of atmosphere while the density of air is lower in the upper layers of atmosphere. Now look at this air column. In this air column we can see that more number of air molecules are present in the lower layers of atmosphere, while less number of air molecules are present in the upper layers of atmosphere. So from this image we can infer that the air molecules are higher in the lower layers. So the lower layers of atmosphere contains more water vapor and dust particles. Now these water vapor and dust particles trap heat. So in lower altitudes we feel warmer. Now as altitude rises, the air becomes thinner and therefore places located in higher altitudes have lower temperature because the air in upper layers of atmosphere has less water vapor and dust particles to trap heat. Therefore, places located at higher altitudes have lower temperature. So here we have discussed about another factor that affects the distribution of temperature across the globe, and that is altitude. We discussed that lower altitudes have higher temperature and higher altitudes have lower temperature. So temperature and altitude are inversely related. Now, there is another important factor that affects the distribution of temperature across the globe, and that is circulation of winds. Look at this map. In this map, we can see some arrows that are marked in blue and some arrows that are marked in red. The arrows that are marked in blue represents the cold winds, while the arrows that are marked in red represents the hot winds. Now, cold winds generally originate in the polar regions and they move towards the equatorial regions. These cold winds usually lower the temperature of places over which they blow, while the hot winds originate near the tropics and they move towards the polar region, and these hot winds usually erase the temperature of places over which they blow. Look at the direction of this wind. Here we can see that the wind blows from land to sea. So this represents an offshore wind. Now, these offshore winds are usually very dry and they cause no rainfall to places over which they blow. On the other hand, onshore winds blow from sea to land. See, this wind is blowing from sea to land. So, this wind represents an onshore wind. Onshore winds are moisture laden and they bring substantial rainfall to places over which they blow. So here we see how the circulation of winds affect the distribution of temperature across the globe. Now, the circulation of ocean currents has a similar influence over temperature. In this map, the arrows marked by red represents the warm currents. The warm currents originate in the equatorial region and they move towards the poles. The warm currents usually raise the temperature of places. On the other hand, the arrows marked by blue represents the cold currents. Now, the cold currents originate in the polar region and they move towards the equatorial region. The cold currents decreases the temperature of places. Now, you can pause the video here and use the iDictionary feature to revise about the circulation and impact of ocean currents. So here we see that the circulation of ocean currents also has a significant influence on the distribution of temperature across the globe. Here we have the map of India. Here we can see the location of two places, namely Surat and Nagpur. Here we can see that both the cities are located on the same latitude, and that is 21° north latitude. Although both the cities are located on the same latitude, it has been observed that the average temperature of both these cities varies. The average temperature of Surat in summer months is 30°C, whereas the average temperature of Nagpur is 35°C approximately. So we can see that Surat has a lower temperature than Nagpur, although both are situated on the same latitude. This is very surprising, isn't it? Now let me tell you that Surat has a lower temperature because it is situated closer to a water body, that is Arabian Sea. So now let me explain you the advantage of being situated closer to a water body. During day, the land gets heated up faster than the sea. So the land is comparatively warmer while the sea is comparatively cooler. Now the air above the land gets heated up and expand. Now this hot air rises, creating a low pressure area over the land, while the air above the sea is cold and dense. This cold dense air sinks, creating a high pressure area. Since the pressure over the sea is higher than the pressure over the land, so a cool breeze blows from sea towards the land. This is known as sea breeze. At night, the conditions are reversed. This is because the land cools down faster than the sea. So, the land is cooler while the sea is warmer. Now, the air above the sea absorbs the heat and expands. This hot air rises, creating a low pressure area over the sea, while the air above the land is cold and dense. This dense air sinks, creating a high pressure area over the land. Since the pressure over the land is higher than the pressure over the sea, so a cool breeze flows from land towards the sea. This is known as land breeze. This land breeze and sea breeze creates a moderating effect over the coastal areas, and therefore Surat, that was situated closer to a water body, experiences lower temperature than Nagpur, which is situated in the interior of the country. Have a look at this image. This image shows the weather conditions of Assam for 13 June 2022. Here we can see that the highest temperature for that day was 27 degrees Celsius, while the lowest temperature was 25 degrees Celsius. So here we can see that there was not much significant variation in the highest and lowest temperature for that day. Also note that the amount of humidity was 85%. Now look at this image. This image shows the weather conditions of Agra, which is situated in Uttar Pradesh, for the same day, that is 13 June 2022. Here we can see that the highest temperature of the day was 42 degrees Celsius, while the lowest temperature was 33 degrees Celsius. So here we can see that the difference between the highest and the lowest temperature for that day was quite significant or quite higher. Now let's have a look at the rate of humidity. The humidity of Agra for that day was 27%. Now let us make a comparison between these two places. In Guwahati, the humidity was 85%. While the difference between day and night temperature was quite low. The highest temperature was 27 degrees Celsius. The lowest temperature was 25 degrees Celsius. So the difference between the highest and lowest temperature was of 2 degrees Celsius. On the other hand, the highest temperature of Agra for the same day was 42 degrees Celsius and the lowest temperature was 33 degrees Celsius. So there was a difference of almost 9 degrees Celsius between the highest and the lowest temperature. So here the difference between day and night temperature is quite significant or greater than the difference between day and night temperature of Guwahati. So here we see that the places that have higher humidity have less variation in day and night temperature, while the places that have lower humidity have greater variation in day and night temperature. Now let us understand the reason behind this. The reason behind this is humidity, or the presence of moisture or water vapor in air. We know water vapor is a potent greenhouse gas as it traps the sun's heat. So more is the cloud cover in the places, more sun's heat will be trapped by the water vapor. Now since substantial heat is absorbed by the water vapor, so during night the temperature does not fall significantly, or there is not much difference between day and night temperature. While the places that have little cloud cover or less humidity have greater variation in day and night temperature because there is less amount of water vapor to absorb the sun's heat, and therefore at night the temperature falls rapidly. So here we see how the presence of humidity affects the distribution of temperature. Humid places have less variation in day and night temperature, whereas arid places where the humidity is less have greater or significant variation in day and night temperature. Here we have a pictorial representation of the location of two places, namely Mount Indrasan and Kulu Valley. Mount Indrasan is situated at an altitude of 6,221 meters above the sea level, whereas Kulu Valley is situated at an altitude of 1,279 meters above the sea level. This peak is Mount Indrasan, while this entire valley is Kulu Valley. Now we can also see that the temperature of Mount Indrasan is 3 degrees Celsius of that day, and for the same day the temperature of Kulu is minus 2 degrees Celsius. Now just notice that the temperature of Kulu Valley is lower than the temperature of Mount Indrasan, although it is situated at a lower altitude. Now this is very surprising because we know that temperature decreases with increase in altitude, but here we see that temperature increases with increase in altitude. Let us now find out the reason behind this. The reason is that in calm and cold winter nights, the heat from the Earth's surface escapes rapidly. As a result, the air lying above it absorbs heat and expands. This warm air rises. Again, the cool air sinks down from the sides of the mountain towards the valley. As a result, the temperature in the valley falls down while the upper slopes remain warmer. So here we observe a reversal in the normal behavior of temperature. That is, temperature decreases with increase in altitude. This anomalous behavior of temperature or reversal of the normal decrease in temperature with altitude is known as temperature inversion. In this phenomena, we observe that as altitude rises, temperature increases instead of decreasing. So this phenomena contradicts the normal lapse rate. We know in case of normal lapse rate, temperature decreases by 1 degree Celsius for every 165 meter of ascent. So in case of normal lapse rate, we observe that as altitude increases, temperature continuously decreases. So this is the normal case. While in the reversed case, that is in higher altitudes, we observe that upper slope gets heated up while the valley cools down. That is, temperature increases with increase in altitude, and this phenomena is known as temperature inversion. So we see that apart from altitude, the slope of the land also plays an important role in determining the temperature of a place. Now before we proceed with our lesson, let us try to answer this question. The change in vertical distribution of temperature on a cold winter night and in higher altitudes is called conduction, convection, radiation or temperature inversion. Well, the correct answer is temperature inversion. And as a result, the valleys have lower temperature while the peaks have higher temperature, and this phenomena is called temperature inversion. Now look at these two images. Now which place do you think will have higher temperature? The rainforest or the deserts? Well, the correct answer is the deserts will have higher temperature. Let us find out the reason why. So, deserts have higher temperature, or the places with little vegetation cover have higher temperature, while the places with more vegetation cover like the rainforest have lower temperature. Now why so? This is because the trees absorb large amount of solar energy, and also the trees utilize this solar energy in the process of making food. So the places that are covered with more number of trees absorbs sun's heat, and these sun's heat are again utilized by plants. So places that have substantial vegetation cover experience comparatively cooler temperature than the places that have little vegetation cover, because the trees absorbs the sun's heat and this solar energy is in turn utilized by the plants. Now the places that have little vegetation cover experience higher temperature because there are no trees to absorb the sun's heat. So the ground gets heated up and they have higher temperature. So here we see how the vegetation cover affects the temperature of places. Now you must have noticed that it is very difficult to walk on sand barefoot, while you will find it much comfortable to walk on grass barefoot. Why is that so? This is because the sand has higher heat capacity or thermal conductivity. That is, the sand can absorb or retain more heat, while clay soil or loamy soil has less thermal conductivity or lower heat capacity. That is, they can absorb or retain less heat. Also, let me tell you a fact that soil that contains more water vapor gets heated up or cools down less rapidly than the soil that contains less water. And we know that sand can absorb less water, so the sand gets heated up and cools down more quickly, while clay soil and loamy soil can absorb more water, so they get heated up or cools down less quickly. And therefore, since sand can absorb more heat, therefore we find it very difficult to walk on sand barefooted, while clay soil or loamy soil can absorb less heat while they get heated up less rapidly, and as a result we find it much comfortable to walk on clay soil or loamy soil. So the places that are covered with sand will obviously have higher temperature, while the places that are covered with dark colored sand, that is clay soil and loamy soil, will experience lower temperature. So here we see that the type of soil present in different regions affect the distribution of temperature in those regions. Now again we have a weather chart on Kolkata and Guwahati for the day 13 June 2022. We will now calculate the difference between the highest and lowest temperature for this day. We can see that in case of Kolkata, the highest temperature is 36 degrees Celsius, while the lowest temperature is 30 degrees Celsius. So now let us calculate the difference between these two temperatures. That is 36 minus 30 equals to 6 degree Celsius. So 6 degree Celsius is the difference between highest and lowest temperature for this day. Now let us calculate the same for Guwahati. The highest temperature of Guwahati is 27 degrees Celsius and the lowest temperature is 25 degrees Celsius. Now the difference between these two temperatures is 2 degrees Celsius. So the difference between highest and lowest temperature for Guwahati is 2 degrees Celsius. So in the previous slide, we calculated the difference between the highest and lowest temperatures for a single day. Now this difference between the maximum and minimum temperatures on a single day is called diurnal range of temperature. So range of temperature is the difference between the maximum and minimum temperature, and diurnal means for a single day. Now in case of Kolkata, the range which we calculated earlier was 6 degrees Celsius, while in case of Guwahati it was 2 degrees Celsius. Now a type of range of temperature is the mean monthly range temperature. The mean monthly range temperature is the average of mean temperatures of all the days in a month. Now look at this chart. This chart shows the mean monthly range temperature of Kolkata. And here the mean monthly range of temperature has been calculated by subtracting the highest, that is the maximum, and the lowest, that is the minimum temperatures of all the days in a month. So for this month of January, the average of the highest and the lowest temperatures has been taken. Similarly for Feb, March and for rest of the months. Now the average of these mean months have been taken, and this is how the mean monthly range temperature is calculated. Now another type of range of temperature is the mean annual range temperature. It is the difference between the mean temperatures of the hottest month and the coldest month in a year. So the mean temperature of the hottest month is subtracted from the mean temperature of the coldest month in a year, and we get the mean annual range temperature for that year of that place. Now this map shows the mean annual range temperature for India. In this map we can see that the mean annual range temperature is higher in the southeastern part and the western part of the country, while the mean annual range temperature is quite low in the northern and the northeastern parts of the country. So the places marked by darker shades represent higher mean annual range temperature, while the places marked by lower shades represent lower mean annual range temperature. So in today's video, we discuss in details about the factors that affect the distribution of temperature across the globe. There are various factors that affect the distribution of temperature, that is latitude, vegetation cover, soil type, humidity. And finally, we discuss about the range of temperature, mean monthly range temperature and mean annual range temperature. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at DeltaStep.com or download the DeltaStep app to learn one-to-one with our amazing teachers, or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million-plus questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.